Hello, we are Team 7 and this is our midterm project presentation. I am Varshik and all of our team members are present. Achyut, Shivani, Nikita, Prasanna and Raju. We currently are implementing an object-oriented solution to make ROS2 easier to implement. And this is the command we need to use to launch the file. And then we get an options to choose. To launch the gazebo file, we need to press 1 and it asks the input for the number of wheels. And we have some custom-made models like 2, 4, and 6. And we press 2, it asks for the laser sensor. What do we need for the rover? As you can see, we have a laser sensor, 2 wheels, and the third wheel is a caster wheel. So we have only considered the 2 wheels for taking the input and not the caster wheel. We have also we also have a command for rover controlling the rover using the teddy similar to turtle scene. Here we can give input commands from the command line to control the rover. As you can see, the rover is moving, and we can also set the velocity control using the command line. You can see the rover speed has increased. You can see the rover is rotating, and we can also now the rover has stopped, and we can see that these are the commands we have used. This is the command line interface where we given inputs like W to go forward and S to go backward, D to rotate clockwise and A to rotate anti-clockwise. We can set the velocity control using Q and D, and we can exit out of the velocity control C. When we move forward by pressing W, it automatically enters the velocity control, and we can exit the velocity control using C. We can use R to stop the rover and X to exit the program. This is the rover controller we have been using, and we have also written commands for we have also written scripts for setting up the environment. As you can see, when you press 3, we get options to install all the required setup. And when you press 1, you can see you can see the Python is installing. We can see that Python is successfully installed, and to install ROS, we need to give input. You can see that ROS is installing. We can see that ROS is installed, and to install Gazebo, we need to give input. I already have Gazebo in my system, so that's why we got this message. And to install Slam, we need to press 4. Yeah. As you can see, we've installed Slam, and to exit, we need to press 6. And to test these installations, we need to give input command 4. And to test Python installation, we need to press 1. As you can see, the Python version is being displayed. It shows that Python has been installed. And to test ROS installation, we need to give the command 2. As you can see, the turtle sim window popped up. This shows that ROS2 has been installed in the system. And to test the Casimo simulation, we need to see. You can see that the Gazebo window has been opened, and this shows that Gazebo has been installed. To test SLAM installation, we need to F4. As you can see, the RGS window has popped up, and this is Gazebo. You can see as the rover is moving, we can map it to here in the RVs, which shows that the SLAM has been installed. SLAM is what integrates the Gazebo and RVs. So, and we also have an input to launch ROS. So when you launch ROS, it created multiple nodes to, and we also have implemented object detection. See that. As you can see, we have the laser sensor, and it can be used to detect objects. You can see that it is detecting that there is an object in front of it. And you can press in input 6 to exit out of the lab. Thank you. This is a demo what you have done until now.